Welcome to AP Physics C Prep Day 4, Part 1. Topics for today are going to be second derivatives, which we're going to spend very little time on, and applications, which we'll be spending most of the day on. By the end of this lesson, you should be able to take the second derivative of a function, determine whether a function is increasing or decreasing, find the critical points of a function, find the local maxima and minima of a function, and solved optimization problems. This unit involves a lot of vocabulary, so let's go over a bit of vocabulary here. You may wish to have this sheet with you while you go over the next few videos. First unusual term is a minima. Minima is the plural of minimum, so if you have more than one minimum, you have several minima. Maxima is the plural of maximum, so again, if you have more than one maximum, you have several maxima. Extrema is not that thing from Iron Man 3 that makes you turn into an exceedingly strong burning person. An extrema is both the minima and the maxima. So if you're finding the extrema of a function, that means you're finding the minima and maxima of that function. Now, just to make things really nice and complicated, you've got two different types of maximums and two different types of two different types of maxima and two different types of minima. One type is the absolute or global maximum, which is the highest point in a domain. Similarly, an absolute or global minimum is the lowest point in a domain. So across the entire domain, you have only one absolute maximum, and you only have one absolute minimum. And for this unit, absolute and global are synonyms. Now, within a domain, you can potentially have several, or possibly no, relative or local maximum. And these are the highest points in a neighborhood. Local or relative maxima look like a peak on a graph. Similarly, you can have relative or local minima, which are the lowest point in a neighborhood in a small portion of the domain, and these look like troughs on a graph. Troughs or valleys on a graph. We're going to spend a lot of time locating the relative and local maxima and minima, and one key factor in doing that is locating the critical points. The critical points are where the derivative of a function is 0 or undefined. So a critical point is where the derivative is 0 or undefined. Now, there's a little bit of one-way logic, so you have to be careful here. All of the relative extrema, in other words, all the relative mins and maxes, occur at critical points. But not all the critical points are relative mins and maxes. How do you know what type of critical point you're dealing with? Well, what you do is you test the derivative of the function just before a critical point and just after a critical point. So obviously, step 1, find the critical points. Step 2, test a number a little bit before and a number a little bit after the critical point, and don't test it on the function itself, test it on the derivative. So you want, just a reminder, we're testing the derivative of the function before the critical point and the derivative of the function after the critical point. And you don't even have to work it all out. All you have to do is figure out whether the derivative is positive or negative. So if you have a combination of positive and positive both before and after, then you actually do not have an extrema. You do not have a relative minimum, you don't have a relative maximum, you don't have an absolute minimum, you don't have an absolute maximum. Same thing if you've got a combination of negative and negative. In other words, if the sign of the first derivative does not change before and after the critical point, then you don't have a relative extrema. But if you do get that change, then you can even start classifying based on that change. So if you go from positive derivative to negative derivative, then you've got a relative maximum. In other words, before the critical point, the function was increasing. Afterwards, it's decreasing. That'll create a function that kind of goes like that, if you can follow my laser pointer. The opposite is also true. If you go from negative first derivative, or negative derivative, which is decreasing, to positive derivative, which is increasing, then you have a relative minimum. In other words, you go something like that, again, which gives you a trough or valley, however you want to describe it. All right, keep this slide handy as well. It'll be useful and help you understand the next few. Bad news is this day is an 11 video day. I'll try to keep the homework to a bit of a minimum so that you can so that we stay within a 3-hour limit for the day, but this is still going to be a bit over 2 hours. Also, to keep things keep the timing to a minimum, I did not include a song at the end of this playlist. Here's the URLs. The videos will play automatically if you're using AP Physics, the AP Physics C Day 4 playlist. The bad news is it's long. The good news is, though, that personally I find, especially the last few videos on optimization, they're actually really interesting applications of calculus. So I hope you find it intriguing.